Hey ambassadors! Are you guys ready to learn new things and lessons? The House of Gamaliel from 11 Ezra are here to provide you some new knowledge. So what are you waiting for? Let's go! So what is a trigonometric function? Trigonometric function is a branch of mathematics concerned with the relationship between the angles and side lengths of a triangle. In particular, the trigonometric functions relate with the angles of a right triangle with the ratios of its side lengths.
Now, let's talk about trigonometric identities. Trigonometric identities are used to calculate the values of trigonometric functions such as sine, cosine, and tangent, and for various angles. We will be knowing trigonometric identities using superhexagon. Now let's draw a superhexagon here in our paper. First, 1, 2, 3, 6. Then we will label each of the sides of these hexagons. First is sine, tangent, and then second. And for this side, here we will put all of the letter C in our trigonometric function, which are the cosine, cotangent, and cosecant. And in the middle of this hexagon, we will draw a line there. And here in the middle, we will put the number 1. That is how we draw the superhexagon. I'll show you right here, like that. Now, let's first talk about the reciprocal identity. Let us remember that this one is the reciprocal of this. This is the reciprocal of this, and this is the reciprocal of this. Now, let's imagine that there is an arrow going there. That arrow means that sine is equal to 1 over cosecant. And if there is an arrow going right here, like that, then it means that cosine is equals to 1 over secant. If there is an arrow going right there, it means that tangent is equals to 1 over cotangent. So that is the reciprocal identity. You can always get the reciprocal of identity by imagining that here in this hexagon there is an arrow pointing towards the other one. After the reciprocal identity, we will now be talking about the quotient identity. Now let's again imagine that there is an arrow going right there from sine to cos to cotangent. Now, from where the arrow started, it means that sine is equals to cosine over cotangent. It is always right there, like that. There is an arrow going right there. So, what if there is an arrow coming from second to sine? It means that secant is equals to tangent over sine. Next, let us imagine that there is an arrow going from cosecant to cosine. Well, that only means that cosecant is equals to cotangent over cosine. Now, let's try if you really understand my explanation. What if there is an arrow going from tangent to cosecant? I'll give you 5 seconds to answer the question. If your answer is tangent is equals to secant over cosecant, then you are right. Be talking about the Pythagorean identity. Since this is kind of complicated, just a little, I'll be drawing on this superhexagon. Now let's always look at these 3. 1, 2, and 3. And then by going clockwise, we'll be moving an arrow right there. That is a clockwise going, the arrow is going clockwise. So the arrow came from sine to cos to 1. Well, that simply means sine squared theta plus cosine squared theta is equals to 1. And then if we go in here to the next triangle and we draw another clockwise arrow coming from 1 to cotangent to cosecant, it simply means that 1 plus cotangent squared theta is equals to cosecant squared theta. The next, here at our last triangle, we will again draw a clockwise position of the arrow from tangent to 1 to secant. Then it simply means that tangent squared theta plus 1 is equals to secant squared theta. So here in this picture is that all the arrows are going clockwise. What if the arrow is going anti-clockwise, which means it is all the way around? So let's try to solve it with anti-clockwise. Now, instead of the arrow coming from sine, the arrow will come from 1 to cos to sine. So as you can see, the arrows are now different, coming from 1 to cosine to sine. Then it simply means that 1 minus cosine squared theta is equals to sine squared theta. Always remember that when you're doing clockwise on Pythagorean identities, it is always positive, and when it is anti-clockwise, it will become negative. Now let's try here. The arrow is now coming, instead of 1, the arrow is now coming from cosecant to cotangent to 1. Then it simply means that cosecant squared theta minus cotangent squared theta is equals to 1. And for the last one, secant, from secant to 1 to tangent. Then it simply means that secant squared theta minus 1 is equals to tangent squared theta. Now we talked about the three trigonometric identities, which are the reciprocal identity, Pythagorean identity, and the quotient identity. Now let's move on to the solving of this using these three trigonometric identity into solving.
We have 1 plus tangent squared theta is equal to secant squared theta, and the other one is sine squared theta plus cosecant squared theta is equals to 1. For our first example, we can prove this because we can see here that 1 plus tangent squared theta is equal to secant theta. For our second example, we can prove this because we can see here that sine squared theta plus cosecant squared theta is equals to 1.
Tangent squared theta plus sine squared theta plus cosine squared theta. First, we need to simplify sine squared theta plus cosine squared theta. Sine theta plus cosine squared theta is equals to 1. So we have tangent squared theta plus 1. Tangent squared theta plus 1 is equals to secant squared theta. So the answer is secant squared theta. Next, cosine theta plus sine theta times tangent theta. First, we need to simplify the tangent theta. So, the next is cosine theta plus sine theta plus sine theta over cosine theta. We need to multiply this to have sine squared theta over cosine theta. This cosine theta is we need to multiply in cosine theta over cosine theta. Now we have cosine squared theta over cosine theta. We can write this cosine squared theta plus sine squared theta over cosine theta since they have a same denominator. So, cosine theta plus sine squared theta is equals to 1. So we have 1 over cosine theta. 1 over cosine theta is equals to secant theta. So, the answer is secant theta.
Hi everyone, I have a trivia. Did you know you can cross a tangent? Because it always going to a different angles.
Did you know trigonometric functions are behind GPS calculations? Satellites use these functions to determine positions by calculating distances and angles.
This is the House of Gamaliel, ready to accompany you on your journey to victory.